So hi everyone, thank you all for showing up on time. Just a quick disclaimer before we begin, I'll be recording this session and feel free to turn on your cameras if you're comfortable, but do keep your mic muted during the presentation. And of course, feel free to drop any questions into the Zoom chat and the other Club Exco members will help to answer them along the way, or you can ask them during the dedicated Q&A session later. So it is now 8:05 p.m. and I'll begin with today's session. So a very warm welcome everyone to Blockchain at NTU's information session and Bitcoin Basics workshop. I'm Reese, the education director for the club, and I will be your host for today. By the end of this session, you should have a clear idea of what Blockchain at NTU is all about, the outline of activities we have planned for the upcoming year, and hopefully you will decide to join us. You can look forward to an introduction to Bitcoin by one of our club advisors, Dr. Surath. We hope that you are excited to begin your journey to expand your knowledge about the blockchain space. Simply put, blockchain is an innovation of distributed database technology, and it lies at the intersection of many related academic fields. You might have heard people describe blockchain to be secure, immutable, and decentralized. By integrating concepts of computer science, cryptography, economic principles, and business models in its implementation, blockchain has achieved these distinct properties over traditional databases. This should also clear the misconception that blockchain is purely computer science related, and this multidisciplinary aspect is also the reason why blockchain has such a wide range of applications today. On the right, you can see how an implementation of blockchain requires an ecosystem of different well-thought segments to work properly. Some of those words like consensus mechanisms may be the most familiar to you if you have heard of proof of work or proof of stake. But the point is that blockchain really encompasses many things if you were to break it down. Now, some of you might have the impression that blockchain is too complex and too technical, but let me give you a few reasons why you should at least try to learn it. First, I'm certain that most of you here might already know that the market for blockchain research and solutions is growing rapidly. And this is creating an emerging market that's very likely here to stay. And I can see why it is creating a driving force for people to start picking up this new skill. Secondly, for the career-oriented, the skill to understand blockchain terminology will present you new opportunities or help you to differentiate yourselves from others. Finally, it is likely that blockchain will be used to support financial infrastructure and as we potentially use in our daily lives in the future. As the backend infrastructure slowly shifts to a more decentralized state, end users on the front end may not even notice it. But wouldn't it be cool to know how it works behind the scenes? So this also opens up the possibility for you to create the next revolutionary application or product of the future. So with all that introduction to blockchain, it is time to introduce ourselves as a club. We were officially incorporated back in 2018, dedicated to fostering a vibrant blockchain community in NTU and beyond. At our core, please mute your mic if you can. Thank you. At our core, we are an interest group for anyone interested in blockchain, and we are here to support you in your learning journey. No matter your experience, as long as you have an interest in blockchain-related topics, we welcome you to join our community. I am sure that you will take away something useful, make some friends, and benefit from the resources and opportunities that we have to share. And to share a fun fact, our official club name is Blockchain at NTU, with the @ as a symbol. You might also see the acronym BNS, which stands for Blockchain at NTU Singapore. Now, some of you might also be wondering why we are called Blockchain at NTU, rather than say NTU Blockchain Club. This is because one of the co-founders of the club was inspired by the Blockchain Club at UC Berkeley, which was called Blockchain at Berkeley for them. So this is why our name is unique in this manner. And in the pictures below, you can see we had some pretty interesting physical events back when COVID-19 wasn't an issue. But we definitely want to keep the spirit of learning and applying blockchain high through alternative events that we will share later. So moving on to our club hierarchy, we have the main exco, a group of members who are dedicated to helping new club members familiarize with blockchain. They will drive the direction of the club, plans and organizes regular events for our members. And for those joining us, have prior background in blockchain and are willing to contribute to the club, we do have a few exco slots that are open, so do look out for those next week. And next, if you're thinking why we have something called student ambassadors, which is a subset of the club members, that is just a term we use to differentiate the more active members in the club, and they're usually the ones that we will look out for to become the next exco. Finally, the club has had some interactions with local and international blockchain organizations in the past year. So as a club member, you will definitely be receiving constant updates on blockchain events that will once again help to accelerate your learning. For those who are more experienced, there will also be webinars that focus more on the advanced topics or even hackathons. So I would say that there will be activities that suit everyone. Moving on, we do have 3 focus areas in the club, though we do not distinctly separate the related activities. The education aspect refers to our core training curriculum, which helps those without prior knowledge to get up to speed with the fundamentals. Our goal is to equip you with sufficient knowledge so that you will be able to self-learn the other more advanced aspects of the blockchain space. And with regards to development and research, we understand that we attract the technical engineers as well as the business people. So here we are just trying to highlight that we do incorporate development related activities which are more coding focused, together with the research related activities which we have categorized to be more towards the business concepts. So if you have coding knowledge, you can find people with similar interest to join a blockchain hackathon, or if you have more finance knowledge, you can look to people of similar interest to research on, say, like an automated market maker algorithm or analyze new blockchain startups. Overall, we believe that most will be able to find an area that they're interested in. And our overarching goal is for everyone to go from a state of understanding blockchain to implementing blockchain and finally to improving blockchain. For our club activities, we have 3 main categories: student-led activities, sharing sessions, and project discussions. Student-led activities refer to our internal workshops held by the Exco team, which has a planned schedule as I will be elaborating on shortly. Sharing sessions include member-led presentations and talks by external speakers or seniors. Lastly, project discussions include the time allocated to hackathons or even discussions about new blockchain startup ideas. Regarding the content thus far, the few keywords will summarize most of the topics that we'll cover throughout the year. So here's a diagram to summarize the planned workshop schedule that we have for our club members this first semester. We have termed this our core training, as these internal workshops hosted by the Exco members are targeted at helping those new to blockchain to get a good grasp of the fundamental concepts. Hence, you can see for the first few topics, they are more introductory. We have also maintained a mix of coding development as well as business related topics. The main theme of semester 1 will revolve around the concept of the blockchain trilemma, which basically encompasses important topics like scalability, security, decentralization, and their respective trade-offs. Next, you might be curious about the member sharing session. This will come after all the introductory workshops, and the idea here is that this will be a group project for you to work with other club members and apply the knowledge that you have learned. We plan on having 1 group project per semester, and in Sem 1, it will be more research-based, where you will look to understand an existing blockchain project and present on it. We hope that these projects will make our sessions more interactive and give you an avenue to practice and evaluate your blockchain knowledge and skills. The semester 2 schedule will likely be focused on the topic of DeFi and NFTs, decentralized finance, as well as non-fungible tokens, as well as a second group project that might be something along the lines of a blockchain innovation pitch. These details are still being confirmed and will be updated accordingly. Lastly, there will be ad hoc career sharing sessions, and we will try to leave some free time for hackathons. Now, regarding the commitment involved, you can see that our club activities will regularly take place on Thursday nights. We highly encourage members to attend all these sessions that we have planned for you. However, we also understand that there will be a few cases where members may have some clashes with your other commitments on Thursdays. Since we are an interest group at heart, we definitely want to grow the blockchain community as much as possible, and we will not reject you from joining us. Instead, in those special cases, we will try our best to help you by sharing the workshop recordings, for example. So even if you can't make it for our regular Thursday activities, we will then expect you to at least participate in the other events or hackathon opportunities along the way. Because you should remember that at the end of the day, how much you learn and improve will likely be dependent on how much you are willing to put in. So I would say that if you decide to join us, you should look to participate in as many activities as possible, which will be the best way that you can learn at a faster pace. And if you ever wish to refer to our club schedule again, you can find it on our Blockchain NTU website. And next, this is an interesting slide that maps out your potential journey with us. Assuming you have no prior knowledge, you will first go through our internally hosted workshops that covers the introductory topics, followed by the intermediate ones. Then along the way, you might register for some external webinars and talks. And by then, we hope that you will likely have gotten to a stage where you can actually ideate a personal project to start working on. So we do attract both computer science and business students. And for the technical engineers, you could go on to secure blockchain related internships. And for the business people, you could go on to pursue a blockchain venture idea. Whichever path you choose to take, it will be an extremely exciting and fulfilling journey. So now it is finally time for me to introduce you to Dr. Surath, one of our club advisors, who has prominent expertise in the computer science, mathematics, and engineering fields. He will be sharing a little more about Bitcoin, the prominent cryptocurrency that has been well associated with blockchain. So without further ado, Dr. Surath, please.
Thanks a lot, Reese. Hi, hello everyone. It's really a pleasure to be with you today. Hello. Some of you already know me through other courses, hopefully. All right. If you're from the first year, then I'm probably teaching some of the sessions in Introduction to Computational Thinking. So I'll see you in the tutorials, maybe in the labs. And in case you're in year 2 or beyond, then you have seen me in other courses like data science and AI. All right. Welcome again to the club. I'm really glad that you're taking interest in this space of Bitcoin, blockchain, cryptocurrencies, and so on. And well, we'll see. We'll see how things go with this first introduction. So I was debating about how do I go about it? Do I go full on technical? I talk about all the details of Bitcoin in the most technical format, or maybe I go more of a storytelling format, just telling you what you may expect when you come across Bitcoin, blockchain, and so on. So let's see which way we can go, depending on your orientation as well, depending on your interest and how you look at the subject, what aspects of the subject interest you, right? All right, for those who know me, I am keeping an eye on the chat. Please do respond in the chat or maybe ask me questions during the chat. All right. And then I can try and answer back. Feel free to unmute yourself and ask me a question if you want as well. All right. Cool. Riz, can I share my screen and go ahead with this?
Yep. We have given you co-host, right?
Oh, thank you. Lovely. All right. Thank you. So just, can you see there's a slide that you can see, hopefully. Grace, can you see the slides?
Yes, we can.
Okay, lovely. Thanks a lot. Cool. So let's start. So I took the route of more about just getting an idea of what Bitcoin is and what blockchain is in the context of what you may have seen so far, or maybe something that's completely new to you. Is there anyone who is completely new? Why are you here? I mean, I just want to know if you are here mostly for just sort of networking, get to know blockchain. Is it your first session in blockchain or Bitcoin? Or have you some experience in blockchain? Completely newbie, fine.
It's also first time as well. Like I don't know much about it, so I thought it'd be good to get a little intro.
Okay, perfect. That's good. That's good.
I came across a site called as coindemo.io.
Very good.
So I was just trying and understand what is blockchain. So from there, eventually I started. I mean, I don't know much. It was just like.
But you did start. Pretty good. Pretty good. Okay. At least you started learning and then you sort of found out some places to get resources from. Not bad, not bad. Somebody lost 400 USD in crypto. Sorry for you, mate. But it's okay, I guess. It's a hot topic. No doubt it's a hot topic. There are so many things going on. Zero knowledge, Ernest, no issue. By the way, zero knowledge is a protocol and a proof system in cryptography, which would be connected with blockchain if you go into the depths of it. So that's a very different story. Cool. Invest in a bit crypto. So we'll learn. Fine, fine. So more the technicals, right? Let me see how much technical we can cover, but it's just about an hour that we're going to discuss on this topic. So we may not go full on technical. Fine. So if you really want full-on technical introduction, what I'll do is I'll leave on trails for you to learn on your own. And again, as Riz mentioned, the club will definitely help you do more of hands-on programming and getting into blockchain dev. I'm not really a blockchain dev, so I do not do development per se. But if you're more of a developer, if you have that mentality to create applications, then the club is your best resource. For me, what I'll do is I'll try to touch upon the internal mechanics, and I'll try to mention how things connect in blockchain in the sense of distributed systems. That's a big area. And then also cryptography to some extent. There is, of course, cryptography. That's where the name crypto derives from, cryptocurrency. So cryptography is there. And of course, there is a bunch of other things like economic game theory in terms of consensus, mechanism design, incentive design, and things around that. Finally, of course, there is a development story to it. There's security, privacy issues. There's, of course, huge financial issues in DeFi, decentralized finance. So put in a very, maybe a nutshell, this is where I belong in the sphere, okay? I come from a cryptography background. That means I understand the cryptography part of cryptocurrencies and Bitcoin and blockchain. I teach data science and machine learning, a little bit of it, as you understand. Some of you year two, you have seen me already. And I study the technical aspects of blockchain. That means I do not understand the economic aspects of it, almost none. The financial aspect of it, if you're more interested in DeFi, decentralized finance, the financial route of blockchain applications, I will again leave you trails and you can start reading on your own, but don't expect it from me as much. I'm not really a finance person. Neither am I an economic person, so I do not know the economic side of game design or mechanism design for that matter. And that's a very different goal. Our another advisor for the club is Prof. Wen Yongang. Prof. Wen is a distributed systems person, and there is a distributed systems course that he offers at NTU. So we together also offer a course on blockchain technology in year 3, year 4. That's an elective. You may take either the blockchain technology or maybe together with distributed systems. That gives you a full overview of why we are doing this from a distributed systems point of view. Okay, let's see. Let's start from here and then go on. Again, any questions, please post it in the chat. I'll try and answer as we go along. Okay, good. Fine, let's begin. So this is what I would start with in general. That there's a Winklevoss comment, right? Winklevoss, famous, infamous Facebook connection. So they have a very strong blockchain connection, by the way, especially Bitcoin connection. If you're interested, take a look. Cryptocurrency exchanges, Gemini is one of their big contributions to this piece. So the comment that we're starting with is we have elected to put our money. First of all, why money? So what's the evolution of money and what has got to do with it? And faith in a mathematical framework. So what's mathematical about it? What are the pieces that we're talking of? And the claim is it's free from politics and human error. And the question that we would like to ask is it? So what's the politics and what's the human error that we're trying to avoid? So let's begin from the very beginnings, right? So what's a currency? What's your definition of currency? Cryptocurrency. So what is currency to start with? What do you think of currency as? Anyone? A unit of value? Sure. A method for transaction? Okay, that's a different point of view. A monetary value for specific things, right? So unit of value for something. Sure. Things that you lost, 400 USD, right, Jinchen? All right. And something to trade with. Sure, value for service could be, yeah, sure. So you're paying value and then so on and so forth. So there's several things that can come in, right, in your mind. So when we start with currency, original stories of currency and so on, it's more of, I would consider the viewpoint that was proposed by Xiaoyang, Mario. I would say it's a method of transaction and then a medium of exchange. That's what we were going with, right? So it's a mode of exchange. Jingtao said as well. Good. So currency, it's a medium of exchange, and whatever you do, it's finally a medium of exchange. Now, when I talk about a medium of exchange, then think of how it evolved over time. Whatever you found in sort of a barter system in terms of goods, you would exchange in terms of goods, and then slowly it got denominations, and you figured out there are units that you can create out of either precious metals, coins, bars, and so on, and then more of a fiat currency, which doesn't have a physical value, but it has a paper value, and you have a stamp by a government. And then that was still physical in terms of currency notes. Then you went digital, so it became a tokenized value. The token is just a number, and then you are just converting or exchanging that. And finally, you have a digital banking system where you don't even have a token for that. You sort of do a digital banking, which means your transactions are just recorded. So think of your transactions as more of just a record of transactions rather than physically transacting something. And if you think of the record of transaction, that makes more sense in a cryptocurrency world. You are really keeping records. So it's more like a message passing system. It's more like a standard, say an international remittance right now on Swift would work by a message passing system. So you are really passing messages and you're really passing transactions as digital data. And the data is being recorded. That's about it. So there's nothing special about it. You're recording it, right? So a centralized accounting, I need an accounting system now. The accounting system is my grammar and mechanism to record my transactions. And what does centralized accounting look like? Very, very simple centralized accounting. Say a two-party transaction, not very complicated, very simple one. I go to a centralized place called a bank. I get some money. I withdraw the physical goods, if there are physical goods associated with the value, coins, cash. I spend it to somebody else, they deposit it back to the bank, they get value in exchange, right? Of course, the link between this Alice and Bob line could be multi-node. Cash could change hands many, many times before it goes back to the bank. That's fine. But that's what we understand as a centralized accounting system, right? Now, can I make it digital? First thing, right? So if you want to make it digital and then you still want to have a sense of connecting it, and you want to have something sort of a decentralized, and you want something kind of a privacy notion and so on, there are several ways to go about it. So for making something digital, you may want to put a number on top of it, an identifier. And then with that identifier, you might say, okay, I have an identifier. So somebody who draws the money from the bank will have that identifier and it's traceable. And then if you send it to somebody else, then they come back and submit it back to the bank. It's still the entire link is traceable. So when you talk about Bitcoin, people would say, well, this is anonymous. We are going with an anonymous digital currency. Is anonymity the main goal of Bitcoin? And it turns out it's not. Because when we started off with Bitcoin, originally, way back, there was a proposal which talked about anonymous digital currency. And this is, by the way back in 1984. So it's my birth year. So at the time I was born, this was already proposed. It's anonymous digital currency. It's based on a design that uses something called zero knowledge proof. Somebody mentioned zero knowledge a little bit back. So there's a zero knowledge proof involved in this, and also something called blind signature. I'm not going in the details of it, but just to grasp the story, think of your digital currency to be like receipts, and you're transferring receipts of transaction. But this receipts of transaction can go through this convoluted mechanism of doing a blind signature. You need to know cryptography to understand what a blind signature is. And then you also need a protocol for transferring something under the hood of privacy. Zero knowledge proofs gives us a private transaction guarantee. So when we want privacy, but also accountability and authenticity of transaction, then zero knowledge proof gives us an amazing way. It's like magic, right? I'm not going in the technical details yet because these are not so easy. Maybe in a year or so after going through blockchain, you'll be interested and then we can talk about it again. But just to put in context, anonymous digital currency is not the goal for Bitcoin, or was not the goal for Bitcoin. This was already there 1980s. Well, so what are we doing here? So the goal for Bitcoin is rather decentralized digital currency. If anonymity comes with it, fine, we won't mind that. But anonymity is not the main goal. The main goal is decentralization. If you look at this anonymity, there is still a centralized authority in play. the bank is still there. So you have to get the blind signature. Signature means the authentication on a bank note. Now it comes from a bank, right? So a bank note, it's authenticated by the bank or the government or something like that, a centralized body. Even with the zero knowledge proof and blind signature, the signature mechanism is still with the bank. So if I remove the bank, then where do I go? So what if anonymity is not enough? And in fact, it's not even the primary requirement. It's decentralization that's our primary requirement. So I don't need the bank in between. And I just want to have one-to-one transactions without involving the bank at all. Does that make sense? So that's our motivation. Again, just to put in context, that's our motivation. And this is the motivation which motivated a bunch of people, known as this group called Cipherpunks. Again, if you're interested, take a look, Google for this, Cipherpunks. This is 1990s, by the way. It's triggered somewhere around anonymity and the decentralization in 80s and then pushed it into 90s. And these are the stalwarts in the field who made Bitcoin or systems like Bitcoin happen the way it is. None of them are claimed to be the author of Bitcoin or the creator of Bitcoin or proven to be, but these are the people who put things together. So Phil Zimmermann, 91, what he did is he said, hey, what is the main thing where everything seems to be centralized? And it turned out at that point when internet, the World Wide Web is being created, most of the things where you needed authenticity, that I need to know whether this server is a good server. I need to know whether the person I'm talking to is the right person and so on. So this kind of a mechanism of authenticity involves digital signature. And at that point, it was being proposed that we have certificates for every single thing. And certificates are the idea of having a certifying authority, an attestation body, attest every single thing. So you are thinking centralized when you think of certification. But Phil Zimmermann's idea was not to go that way. He said, no, let's go with something called pretty good privacy, PGP, which is more peer-to-peer. It doesn't involve a certification or authority, no centralization, complete decentralization of authenticity. Lovely. That flows back in Bitcoin as the decentralized route of signatures for authentication. So we'll come back and we'll probably check how it works as well. Hashcash 97, by that time, Adam Back came out with Hashcash. What is Hashcash? You have cache, which is based on a hash chain. So a chain of blocks connected with hashes. If it sounds familiar, that's more or less what blockchain looks like now, like a data structure. Hashes and blocks connected. VDAI came by in B-Money, 98, similar idea. Nick Szabo, BitGold, you see back to back almost 97, 98. All of these ideas are same. BitGold is, you can think of it as mostly the first kind of tokenization system coming in. So gold was being pegged, and then that was the asset class. And Nick Szabo said we can do transactions. Lovely. So transactions already came in. Now, the final thing in that entire gamut of innovations was 2004. Hal Finney came in and he said, let me give you something which helps you bring consensus into a distributed system. And he gave us the reusable proof of work. Again, you will hear about this quite often, reusable proof of work. This proof of work gave us the consensus mechanism which built the ledger on top of it. So that's the story of how things evolved. 2008 is when Bitcoin was proposed, but these are people and these are innovations which went into Bitcoin. Okay, so when we come to Bitcoin, I would ask you maybe if you can try to read the paper, the original paper of Bitcoin. It's a 2008 paper. Bitcoin, the first block of Bitcoin was mined in 2009, 3rd of January. So before that, in 2008, the paper was published, so to speak, in the open domain. And if you look through the paper, it's about 7 or 8 pages long, so a pretty short paper, but quite a dense read. It's not easy. It's quite non-trivial to read how things are going. If you are interested, take a stab. Take a look and see if it is something that interests you. Okay, this is 2008. Let me break it down in sort of a conversational way with you and then try to see if it's interesting to you as well. All right, so transaction, right? I mentioned transaction as our basic mode of thinking of currency. So mode of exchange transactions. Now here's what we're going to do. We're going to take a standard transaction mechanism. So a transaction in a centralized environment looks like this. All the parties are connected to the centralized authority, the bank. And then every time you want to do a transaction, you must go through the bank, right? So I'm thinking of transaction not in terms of cash or coin, because then you do not always need to go through the bank. Cash is also transferable hand to hand. So you don't always have to go back to the bank, but think of a digital banking system where all the transactions are purely records. And for the records, you cannot really tell someone, I'll give you some money and it works. It doesn't work that way. You have to tell the bank, I want to give this money to someone, and then the accounting starts operating, right? So there's a centralized banking system, whereas vice versa, we are going with a peer-to-peer system. So centralized to a flat, non-hierarchical peer-to-peer network. So most of the time when we'll talk about blockchain, at least from an academic point of view, we generally mean a peer-to-peer network, no hierarchy. With a caveat, in a practical context, when you talk about blockchain, when you say that we are using a blockchain network in an enterprise, quite often you will find not all blockchain networks are entirely peer-to-peer. You may have hierarchical, semi-hierarchical networks. So peer-to-peer followed by an enterprise network at the backend. That's possible. There are blockchain constructions like that. Channels in Hyperledger and so on would be very common instances of it. But Bitcoin, it's entirely peer-to-peer network, right? So it's a peer-to-peer network where people are at the same level. There is no hierarchy, so to speak, at least to start with. Okay, all right. Now, transaction, how does it look like? Let's start with very basic. So I have transaction, I want to transact, I want to send some amount of value. In Bitcoin, it would be X amount of Bitcoin. If you see, I am calling it X amount of token, quote unquote. So I don't care what that token represents. I'm sort of misusing the word token a little bit here, but let's go along with it. I'm just assuming token means a sense of value. So something of value that someone wants to transfer to someone else. So Alice wants to transfer to Bob some amount of tokens, right? So that's my transaction. That's one transaction. Again, what is transaction? I say transaction is nothing but message. It's just a message, it's a record, and that's about it. There is nothing special about it. It's just a record of transaction that matters, not the actual transfer. So here's a transaction. Alice wants to send to Bob some X number of tokens. What does she do? There is a record of transactions where she wants this transaction to be recorded as well. So this record of transactions is what we'll call a ledger. So the term distributed ledger comes from the fact that there is a ledger or a record of transactions maintained, and you have these records, the new records coming up has to be included in that, right? So transaction, Alice wants to transfer Bob X tokens, goes as a part of the record of transactions. That's it. All right. What is your main requirement out of the ledger? If you are doing this, what would you expect the ledger to maybe ascertain? Or what is the main property that you need in the ledger? What do you think? So there's a ledger where you are recording transactions. Think of a centralized if you want right now. Decentralized, centralized, the same story. If someone wants to give someone money, they try to write this information in the ledger. So it's an accounting system. What do you expect out of the accounting system? Highly secured. So secured as in highly confidential, or secured as in nobody can change it secure? Kangwei, these two are different concepts. So when you say secure, could be mean confidential, or you may mean that nobody can change it. A record of transaction for sure, but what do you want out of it? So what are the properties you want? So Peter said immutable. Immutable means you are not supposed to change the record once a record has been put in. You shouldn't be able to change it, right? Kenneth said more of the functional terms. I need to have the time of transaction recorded and amount per transaction. So faithfully recording those two entities. Sure, makes sense. What else? I'm assuming what Kangwei mean by highly secured is something that Peter also means, which is immutable. You're not supposed to change it. So I'm really trying to protect integrity of the ledger rather than the confidentiality of the ledger. It's not really confidential. I don't care about whether it's hidden. I care about whether it's changeable. right? Okay, what else? Any other suggestions? Can it say time of transaction, amount per transaction should be recorded? That's good. What else do I want? Distributed is the goal that we are going towards, decentralized and distributed. We'll come to that, sure. But from the ledger, forget about what type of network I am on, just the ledger. So it's an accounting system. What do I want? Okay, so if it's distributed, then of course, Vedansh is right, should be universally acceptable. That means everybody should agree on that version of the ledger. That's my global version of truth, and everybody should agree. Okay, good. Permanent, that's very interesting. I want it to be permanent. Permanent means nobody should delete it somehow. So it ties correctly up, it ties closely with immutable. Easily readable, interesting. So you're doing a public sense of the thing, could be. Peter said authenticated, right? So there should be some authentication involved. Authentication is very important for auditing purposes. I need to know who did what. So actions should be authenticated to the person who did the action. So it should be owned by the person who did. Authorized, have to see. Authorization means access controlled. Who can do what? We'll see about it. Free from tampering is the immutable part, absolutely. Right, so we have a lot of concepts, we can put it together. So I need it to be free from tampering, immutable, so sort of permanent and so on. I need it to be authenticated. I need to make sure people own up to their actions and cannot deny it. So that's the authentication part. It should be secure in the sense of immutability. It should be universally acceptable if it's a distributed system. So people should not debate or have a problem over the records. Good. And I'll pick up the one as well from Kenneth, which is time of transaction and amount per transaction. Now, the time of transaction is tricky. What is time in a distributed system? It turns out there is no good notion of time in a distributed system, because the time you see something happening in this network and you sending a message, the time you sent the message and the time someone else received the message in the distributed system are different. Why? Because every network has a latency. And this is a network we're talking about in Bitcoin, which is the entire worldwide network. So I send a message from my end, I see a timestamp, and when you receive it on your end, you see completely different timestamp just because there is no global notion of time. So what I really care about is not really time, but more of an ordering. The transactions should be ordered in a way so it's meaningful. I should not have a transaction which happens before the transaction which came in and so on and so forth. So the two transactions, if one depends on another, the ordering should be preserved. So we'll care about that first. So let's start with it. So Alice gives Bob X tokens, then Bob may give maybe Charles Y tokens. And now here's the thing. Suppose that's the ordering, right? Alice gives Bob X and Bob gives Charles Y tokens. Now, how does Bob give this Y tokens to Charles? So now is the question of the correctness of the transaction. You said it's authenticated, but you didn't say that it's correct transaction. What is a correct transaction? Correct means it's a transaction of value. That means I should own that value in the first place. So when Bob is transacting to Charles and giving Y tokens, how do I even know Bob has that to start with? What do you think? How do I even know Bob has that money to start with? Okay, so the ledger must be available to everyone so that when Bob says, I want to give Charles Y, everyone can check in the ledger. But is it everyone's onus? Does everyone have to verify like a bank? For a bank, I understand. The bank is a centralized body. They get my money, they use my money, hence they are kind of providing me with a service that they also check all my accounts. But here, Bob is just giving Charles some money and then everybody, the whole network is providing this service. That's a distributed network. There is no bank. So why should everyone in the network go to the ledger and check? Is there an easier way for me to say, hey, Bob, can you prove whether you have the money or not? So can I put the proof ownership to Bob? So the shouldn't allow if the person doesn't have it. Sure, proof of work is a different thing, will come there. But how do I make sure Bob proves that they have the money before they spend it? So he's sure. So there are lots of cryptographic ideas that's going on, right? So let's boil it down to the very simple basics. Suppose you give me, I don't know, suppose you give me a pen and I ask you, hey, where did you get this pen? How would you prove you got the pen from something legitimate and not you stole the pen, for example? A receipt. Perfect. So a receipt for either buying the pen or a receipt of getting the pen from someone else and so on. So here is what we're going to do. We have a record of transactions, and then every time somebody makes a transaction like this one, Bob gives Charles Y tokens, we'll make sure Bob has to connect that with a previous transaction that he received earlier from somebody else. So we are connecting all the transactions by receipts. In the accounting system, it's very easy because there's an accounting system where Bob must have received that money from somewhere. And if they receive the money from somewhere, very good. I'll ask them, hey, you know what? If you're planning to spend $10, show me a receipt of receiving, say, $20 from somebody else. If you can do that, I'll allow you to go ahead and spend $10. Does that make sense? So here is what the blockchain network looks like. So this is your Bitcoin blockchain network live as of now. Somebody said the ledger should be public, and it is. That's a Bitcoin ledger. It is indeed public. So if I go into this Bitcoin ledger, then this Bitcoin ledger is constituted a ledger. It's a book, accounting book, constituted in terms of pages, let's say. The pages are your blocks. It's as simple as that. So here's one page of it. That's page number 696517, right? It's called the block height. So that's a block number. Now, this block number, this block has a transaction, for example. This is what the transaction looks like. You see a transaction is from and then to. So this to side is the two numbers that you see over here. These are actually addresses of people to whom the transaction is going. So these are my two addresses. If you look at the from, you will see something very interesting. This from is not really an address where it's coming from, but rather, see, this transaction has a big number on top of it. That's the identifier for the transaction. This identifier is created by using something called hash. So hash function is used in multiple ways. It's generally sort of a fingerprinting application. So if I want a fingerprint of something, I do a hash. So here is a fingerprint of this transaction. This is a unique identifier or a fingerprint for this specific new transaction. That means every transaction has a fingerprint. Good. Look at this one. That is, again, something which looks like a transaction. And it is. This is a transaction that happened earlier. So if I go back to that transaction, see, there's a transaction. That's a transaction through which the address that's trying to spend, they got 3.2346 Bitcoin. They got this 3.2346 Bitcoin earlier from a transaction. And now if I go back, they are trying to use this 3.2346 Bitcoin as the input to a new transaction where they're sending the output to two different parties, one 0.0359 and the other 3.197. So what's going on? What's going on is every time I have to create a transaction, I have to refer back to a transaction that I received in the past. If addresses show up in my output of transactions, and my address showed up in one of those outputs earlier, that means there is an account transaction debited to my account, debited to my name. And if it's been debited to my name, then I can spend it. Cool. So this is called connected transactions. Every time I do a transaction, it has to be connected. And what is a connection mechanism? That's the authentication. That's the digital signature. If I own this money, if this is me, I should be able to prove that it's me. Okay. We'll use digital signatures in cryptography to implement that mechanism. But the implementation is the technical side of it. The concept is I need to connect these two transactions. So that means Alice, when Alice sent Bob X tokens, it cannot come from thin air either. It must have a previous transaction to Alice, which Alice referred to when she created this transaction. So every transaction will have sort of a history. Does it make sense? So you have a history, like every banknote has a history, and you should have a history for the transactions. You can trace back or trace forward. Good. This is precisely where you say that, okay, if everything is connected, why don't I use blockchain for all kinds of connected things? Another example, can you tell me a connected application where you would use this kind of a logic? Something that happens must have a precedence. And then something that happens can also have a consequence. And all these things, precedence, the event, and the consequence have connections. Unless you have the precedence, you cannot have this, and then the next one, and so on and so forth. Give me a practical example, another one that you can think of. And we can see, we'll try to see if we can model it in the blockchain terms. A generation evolution. Okay, sure, can. Chicken and egg. But we don't really know, right, which one is the consequence? The chicken and egg is a famous joke that goes by saying, it's very easy to solve. It depends on what you order first. So everything has to be connected, right? So here this, everything, when you're connecting things, then there are several applications. If you start thinking, you'll find so many applications. A very common application is any kind of an asset exchange. You cannot really buy or sell, say, a house, let's say a house, an HDB or something. If you're trying to transfer the asset to somebody else, you must prove you got it from somewhere. And then the person who gets it can again sell it. So it's a transfer of ownership. Transfer of ownership of asset follows the same architecture. It's just a transaction. And you must prove ownership before you can sell it. Right? That's one. The second that I might take is, let's say, a supply chain. A supply chain is a very common architecture where things are connected. So if there is a party who holds a packet for you, say DHL, and they have to transfer it to the next party, they need to prove the ownership of that packet so that they can transfer it. So it's proof of holding. If the packet is in customs and then the customs gives it to the shipping and the shipping takes it to another customs and then they go to a freight and the freight takes it to a warehouse, the warehouse sends it to, I don't know, a DHL kind of another sort of a local courier, and the local courier gives it to you, then every leg of this entire supply chain is connected. So unless you have the packet, you cannot transfer it to the next person. And again, if you have the packet, I can always ask you, where did you get it from? And you should be able to give me the entire trail back. Good. Another example, again, a blockchain context example. Suppose you go to Starbucks on campus, right? You get a pack of coffee, say a coffee beans. I buy beans in Starbucks sometimes. So you get this bean, right? The pack of beans, 200 grams to 50 grams. And then suppose there's a QR code at the back and you scan the QR code and that leads you to a blockchain where the entire supply chain of this packet of beans is recorded. What would you find? You'll find the entire provenance history for this packet. It will say, okay, so this beans was roasted in so and so place. It's a medium roast of something. And then that roaster will say, I got the beans from so and so place. Maybe it's a blend. And then from that place, I'll know where it was shipped from, which other places do the beans came in to get mixed, if it's a mix. And then I can go back to the coffee plantation. And maybe I'm really concerned about whether this is an ethically sourced coffee or maybe an organic coffee. Then this entire provenance history will tell me which plantation it came from, and I would know if it's an ethical one or an organic one. Right? So that's called provenance. And provenance is based on this simple idea that every single step of your journey must be well documented, must be ordered, and must have precedence that you can prove. Cool? Make sense? So start thinking of any other such application and you'll see blockchain can, in some cases, give you a solution to connect all of these things together. So we're starting with Bitcoin. So Bitcoin just talks about transaction. Transfer of ownership of Bitcoin, the currency that we're talking about. Good so far? Any question? Any burning thoughts? Oh yeah, bachelor degree certification too. Thank you. So you have your degree given by NTU, and then you want to prove it to somebody where you're applying for a job. Then they want to know where you got the degree from, and then that's one. Second is all of your stars requirements when you're enrolling for a course, prerequisites. So if you meet the prerequisites and then things flow into a course, could be a minor or something like that. So several things. Like, no question right now. I was hoping there would be a weird. Thank you. So Vedansh asked a question that I was hoping to hear. What's the origin story? So do we believe in the creation myth for Bitcoin? Where do we go back, right? So if I keep on going back in the provenance route, coffee, I went back to plantation and I cannot go back any further. Bitcoin, where do I go back? And it turns out there is one transaction in this block. If I look at the block, that's a block, right? One page of the accounting ledger. There is one transaction, the first one, if you look at it, it's called a Coinbase transaction. Don't confuse with the name Coinbase. Coinbase is also a group and so on and so forth. It's called a Coinbase transaction. That's the technical name of it. Coinbase transaction has an output. Here's the output, 6.37 Bitcoin. So it seems input, nothing. So what happened? Did it come from thin air? Where did this money come from? 6.37 Bitcoin. That's quite a hefty amount of money. What is it? Value? Aha, nice. More than a standard HDB. Right? So 386,000 Sing dollars right now. That's amazing. That's a huge amount of money. Where did it come from? Somebody said the transaction fee. True, in part. So a part of the 6.37 is indeed the transaction fee gathered from all the transactions in the block. We're going to talk about that. But there is a huge amount, 6.25 Bitcoin, which is generated from really thin air. It's called minting or mining. So minting is a very, very, very common thing, right? So minting is a very common thing in standard currency. A note is minted in a mint by the government. So is a coin and so on. So this is where you're minting Bitcoin. Cool. So this is where you're minting. 6.25 Bitcoin is getting you out of thin air. That's a minting. And the remaining, so 0.12 Bitcoin roughly and more. That portion is getting from the transactions and so on, right? All right. Now we're going to get into a bunch of things, right? I'll answer those things. We'll see. What happens if all the Bitcoin is minted? All right. So all the Bitcoin, what do I mean? So you're assuming that this Bitcoin network has a limit on the number of Bitcoin to be minted. Does it? Yes, it does. So it depends on the construction of your cryptocurrency. Bitcoin has an upper limit. Ethereum does not. So when you think about Bitcoin, then think of this minting to stop at some point. It has sort of like almost like a nuclear half-life, right? So it has a half-life, it halves every 4 years and so on and so forth, right? So that's one issue. Ethereum, for example, doesn't have an upper limit. So it gives you these coins almost regular intervals and it's arbitrary. How do you decide how much the miner gets and so on? We'll come there. We'll come there. Just give me a minute. Good so far? So there's a minting. Let me go into where things come from. Again, we'll come back to this for the minting purpose. All right. So format of a transaction, that's a very basic format of a transaction, is simple now, as you understand. There are this token, the previous transaction that you're referring to. You're creating a new transaction. You can send the transaction to multiple recipients, and then you have to sign. That's a digital signature. You're proving that you owned the previous transaction. Again, so if I go back to this one, a standard transaction like this, if I want to spend it, I have to sign and prove I really own it. That's something which is verifiable, actually publicly verifiable. And I can send the transaction to 2 different parties or even 1 or 3. And you see there are so many options, right? 1-to-1 is rare, as you see. 1-to-2, many to, oh, here's a 1-to-1, interesting. And then there are many 1-to-2 transactions that you will see. So why a 1-to-2 is more common? Anyone has an idea? why it seems like 1 to 2, that's the most common transaction type. Good guess, broker fee. So the broker fee is essentially the transaction fee, which is a different concept. It's this input and the gap of this input and output. If you add these two outputs, you'll find it doesn't match up with the input. The small amount of the gap is automatically considered as a transaction fee. So there is no broker fee, has to be given. Witness, not really gas fee yet. So what's happening here is this. Remember, you are spending this transaction that you owned earlier, and then you're creating this new transaction out of it. So when you're creating this W token to X and Z, there should be a way in the accounting system to know that you have spent this transaction that you had. If you did not spend the entire transaction that you had earlier, then this accounting system will go in a pretty chaotic situation. Suppose you wanted to spend W by 2 now, and then you keep W by 2 for something later. That's not allowed, not in Bitcoin at least. So if that's allowed, then it's a mess, because then you have to keep track of how much is spent of the transaction and how much is left. Rather, what Bitcoin says is, don't do that. If you have a W tokens, spend the entire thing. So destroy the previous transaction, not destroy, make it marked as entirely spent. And if you want to get something back as a change, then do it in your own transaction. So W is this W, that's the token that you had, it splits up in X that you want to give someone, and the remaining is what you give yourself. See, it's yourself. Alice is spending to Alice. So that's sort of a change that comes back to me, right? So these 1 to 2 transactions are mostly change-making transactions. So here, this 3.23 Bitcoin, I'm assuming this is the one that goes to somebody else, and this is the one that comes back to me. Why do I say assume that? Because if it was just the 0.03 to be spent, maybe I could have used a smaller transaction on this side. Maybe I have a 0.05 transaction with me, which is sufficient. But here I'm spending 3.19, that's my guess, that's a spend. So I used a 3.23 transaction to give this 3.19 to someone, this guy, and then I took the remaining back as my change. Right? So that's a change-making transaction. What it does in effect, that's very, very important in the accounting system, is the previous transaction is marked used. If it's not marked used, someone can try to spend it again. That's called double spending, and you're trying to prevent it. So you know which ones are spent, which ones are not, depending on whether it has been used in the ledger earlier. All right, so that's my transaction. And now I need to look at the transaction and say, okay, now comes a point that it's a peer-to-peer network, and I have my transaction. What's the transaction? Again, it's a message, right? It's nothing but a message. So it's a message that I created, I signed, I did a bunch of stuff, I made sure the format is correct, and then I face a peer-to-peer network. There is no bank. Who do I tell about this transaction? Who maintains the ledger? What do you think? If there was a bank, I would have told the bank. So Chinmay said miner. I do not know who is a miner yet. In fact, when I'm joining a network, I do not know all the miners. So I'll go more with Ernest's idea. Everyone, right? So how many of us are here? Let me see. It's 66 participants in the room right now. Let's create a coin, all right? We'll call it NTU coin. So here is how it goes. If I want to give Ernest some money, so I'll say, hey, Ernest, I'm going to give you, I don't know, 5 NTU coin. I'm going to tell it up loud to everyone in the room so that it's properly recorded by everyone and I cannot go back on my statement. So that's called a broadcast. I'm really telling everyone that I want to give Ernest 5 NTU coin. All right? So keep a note, you all listen to it. So it must have happened because I sent that to Ernest. What's my signature? You can see who sent to who. I sent to everyone, me to Sourav. So me to everyone. You should see Sourav to everyone. Means I am also owning up to my action. That's my signature in this context. So in a big network, it would be you tell your neighbors, the neighbors tell their neighbors, and so on and so forth. But as you all listen to it, what would you do first? You note it, but before noting it, you have to check for the validity of it. Can I give Ernest 5 NTU coin? What do you think? Do I have 5 and 2 coin to give? So far in the network? We're just starting our network. So we don't have any coin whatsoever. That means this Sourav gives Ernest 5 and 2 coin. It's pretty bad. I cannot really give N2 coin, 5 and 2 coin to somebody else, right? So there isn't any proof that I'm getting this 5 and 2 coin. Absolutely. So what I'll do is I'll say, I don't know, I'll probably say something like this. Originally, I got from Coinbase transaction, some Coinbase transaction, you don't need to know how, but I got 10 N2 coin earlier. And then I'll do the same thing. I'll say, I now give Ernest 5 N2 coin. That's still meaningful. So now you have 2 transactions. And when you have these 2 transactions, you know I have got 10 N2 coin, and then I'm giving Ernest 5 N2 coin. A natural question to ask is, where did the remaining 5 N2 coin go? And I have to say, hey, okay, I'm making a change. So I will give myself 5 N2 coin. Those last 2 lines are together as one transaction, right? So that's how the transaction looks like. All of you listen to it, hold on to the thought. You know roughly what it looks like now. I got a 10 first, I have 5 still, Ernest has got 5. So everybody verifies this entire thing. You, all of you, verify this. You verify the signature, you verify whether the input and output matches, it does. And then you record it faithfully. Where do you record it? Is there a global ledger where you can go and write? Is there a global database like a Google Docs? Or where do you write this? If I ask you to please take a note, please write it down. Absolutely, Timothy. It has to be your own ledger. It has to be pen and paper on your side. There is no Google Doc which is shared between all of us. So when I say that there is a ledger, an immutable ledger, so to speak, it's just a concept. This immutable ledger is really all of our individual ledgers combined. Rather, to be precise, it should be the maximal length agreed upon component of all of our individual ledgers. All of our ledgers are like a book. So suppose 100 pages of the book has been recorded so far, and those 100 pages of the book has been agreed by everybody. What do I mean by agreed? Agreed means that's a concept of consensus, a consistency check. Everybody knows that 100 pages are correct, right? So there are 2 questions that came in. One is Vedant, who said, do people get something for recording it? Yes, they get a reward. That's precisely where the minting happens, the mining happens. And Timothy said, one question, if I need to broadcast to everyone when making a transaction, if to hear from everyone, then my ledger would be very full of, absolutely. So your ledger is pretty big actually. What's your ledger? That's your blockchain ledger. How many blocks you checked? What is the current block? Let's go back to the dashboard. The current block size, let me refresh it. 696,524 blocks already recorded. And if you want to know the size of it, 581 transactions in the recent block, the size is 1165 KB, which is 1.1 MB. So it's about 2 MB per block, let's say. And if I say that's 2 MB per block and these many blocks are there, you can guess the size of Bitcoin's ledger right now. That's how big the Bitcoin ledger is. It's pretty large, right? It's about a terabyte or so. So you, more than a terabyte, I think. So you're storing that huge amount of information on your system. You're keeping a copy of it. And then that's a copy which is agreed upon by everybody. That's called the immutable part of it, which means everybody agreed to it. And now I have to update it, right? So Ernest said, what do you if you don't update your ledger? Fine, no issue. If you don't update your ledger, you're not going to maintain the system for this time. No issue, because maintenance of a system is entirely optional. You may not. What do I mean by maintaining the system? The ledger is agreed upon up to a level. Let's assume it's 100 pages, which is agreed upon. And then you are writing the next page. And that's what's called mining. Make sense? So you have the immutable ledger. All of the people who are willing, so Ernest is not, fine. But Ernest, you should be willing, right? Because the transaction that went in is to you. So if you're getting a transaction, you should be more than eager to write it to the block. Because unless you write it to the block, the transaction did not happen yet. It's sort of recorded by everybody, but unless it happens on the ledger, until it goes into the accounting system, it did not happen. So I think Ernest should be the most willing party here to write the transaction immediately, right? But you cannot do it immediately, and there's a process. So here's what's going on. So the part where I'm writing to my ledger, a new page, the 101th page, is called mining, right? So it seems like there is one common ledger that everyone records on. No, it is not. Yes, it is a commonly agreed upon ledger, but that ledger lies with physically every single person. It's a distributed system. So think of 5 hard drives that you own, and all the hard drives have 1,000 of your pictures, right? So if you have 1,000 pictures on each of the hard drives and it's completely duplicated, then when you add the next picture, you have to make sure you add the picture to the hard drive 1, then again to hard drive 2, again to hard drive 3. So you have to make the consistent copy on all of it. This consistent copying mechanism is called consensus. That's a consistency argument. We'll come to that. But right now, we are just writing to one hard drive, which is yours, and then you talk about consistency. Cool? So this is what's mining. And who does this? Who writes it? Ernest doesn't want to, that's fine. But who wants to? Farhan said, if your ledger is full, can you delete any record? No. So your ledger, if you're really maintaining the system, you have to keep running it. There's nothing called ledger is full. You have to keep on maintaining that. The ledger is the entire transaction record. If you don't want to maintain the system, don't provide the service, no issue. But you are a part of a bank here, right? You are a part of that banking system. So you must keep on maintaining the account. If you don't want to maintain the system, you can be just a user, a bystander, that's fine. But there are people who are maintaining the system called the miners, and they have to maintain the system. Okay. All right. Here's a question. Who writes to this ledger? Who gets the priority to write on it? Suppose 5 of you want to write it. Who gets to write it? Someone says the miner who solved the hash. So here's a question. Every blockchain has a leader selection mechanism. Fastest would be very hard because everybody can do the transaction recording fastest. And maybe I just do my Coinbase transaction and one extra transaction and I pass it out. That means I keep on producing blank blocks. I will be the fastest. That should not be the case. So to prevent you from being the fastest in a bad way, the idea is we go with the leader selection strategy. And the leader selection strategy is tricky because the leader selection, if I knew all the players who are the leaders, I could have done a random leader selection. But not all the players are known. Bitcoin is completely open to public. So anybody can become the leader. Anybody can take part in this game. So I don't even know how many people are there. If I don't know how many, I cannot do randomization. The other option would be leader election, which is all the people in the game vote on each other and decides who is going to be the leader of this round. Because this block creation is not one round operation. It's every epoch, every round, one block will be created. So I could have done an election, but election again requires me to know who are the parties involved and how do I even elect one? What is the election protocol? And none of this is known as a public network. So what we do is we do more of a lottery. All right, so by chance, but randomization is hard. Randomization requires you to know, uniform randomization requires you to know how many people. Cannot do. So what you do is, I'll do this. All of you are recording this message, right? So what I'll ask you is, I'll ask you this. Factors of 1001. Whoever can find the factors of 1001 can write to the legend. They become the leader for this round. Anyone? Want to give it a shot? Yes, no? Come on. Not the trivial ones, the non-trivial factors of 1001. Is it really 1 and 1001? Or do you have more factors of it? If it's a prime, I don't mind. So you're probably trying to do it on your computer and then trying to find out, okay, factor 1001. Let's see. Factor 1001. Oh, wow, there are a lot, right? So if you're on your computer, you're doing that. 1001 has 8 factors. Somebody said 7 and 143. So you got 2 factors at least. Not bad. So whoever is the fastest, you produce these factors. 7, 143 is an acceptable answer. So Chunwei, you are the leader for this round. How do I know? See, solving the puzzle is not as easy. Solving the puzzle should be hard enough so that you spend some time on it. You're not the fastest anymore, but you are doing some work for it. That's called proof of work. But when you give me the factors, it's very easy to verify. I'll simply multiply, right? So multiplication is a much simpler process than trying to find the factors. Hence, the puzzle is hard, like Sudoku, but checking the solution is very easy, like Sudoku. Given a solution, it's very easy to check. If you can prove that you have solved the puzzle, you have the right to become the leader. And everybody else will accept you as a leader because you are the one who solved the puzzle. Right? So that's exactly what is called proof of work. And that's our consensus mechanism. I need a leader, go with this lottery, give a puzzle. And what kind of puzzle? Big story. We're not going in there. That involves hashes and all those things. I'm not going there, but just assume there is a puzzle which you're solving. It's a computational puzzle. So the bigger your computer, the faster you will solve the puzzle. That's a mining, right? What happens for the next round? Somebody else comes up and then somebody else does the mining again. Right? Now, here's the thing. If you did a mining and somebody else comes up and extends the block behind your block, means you did originally it was 100 pages, then you did the 101 page, and then the 102 page came in here after yours. That's fine, no problem. People will agree to that and we go along fine. However, if you do not have the next person voting for you, means they're not doing a 102 page, rather, what Vedant said, if they want to challenge your page, they can do that as well. So challenge can happen in many, many ways. They can say, hey, I don't trust your page. Your page is wrong. My page is correct. That's an option. They may say, okay, I trust your page, but you know what? I got the puzzle solution at the same time. So I'm going to challenge you anyway. So I'll post my solution at the same time as yours. And I'm going to challenge you. I want to win the puzzle. I want to be the leader. I don't want you. Fine. If you do that, then that's called a conflict. And this conflict is resolved not immediately, but by the next voter. So the next miner comes in. And when the next miner comes in, the next miner chooses to extend one of the blocks. Again, it's a free country. They can choose whatever they want. They may choose the next block based on which one seems more correct to them. All right. Maybe both are correct. Then they can also toss a coin and choose a block. Or they will choose a block based on their version of truth. Means when they see these two conflicting blocks, they already went with one as the correct version of truth for them. So whichever one they chose to be correct is the one they will extend. Now, what about all the other mere mortals out there? We see this blockchain propagating, some fork, this is called a fork, right? So now, Ernest, it's a good question. You don't update your ledger, that is the 5 NTUC you sent, right? You didn't get it. No, you can still participate in the future transactions. What you will do is you will wait. That's a good question. So if you do not update your ledger at the time when you hear the transactions, can you still participate later? Yes, you can. Maybe you shut down your computer, you went home. For a day, you never updated anything. And you came back after one day. What you do is you go to the ledger and you find out how many blocks were mined during that one day. You update those blocks accordingly. So you essentially copy from one of your friends, one of your peers, the current state of truth. If you copy that current state of truth, you are back in business. You can start mining once again. Does it make sense? So yes, that process is also automatic. If you are running a mining software, generally the mining software will update to the blockchain. Don't worry. Yeah. So it will generally update to the current version of the blockchain. So it is not like syncing. It's precisely syncing, Peter. It is what syncing looks like. It is precisely syncing across the board, syncing all across. It's not just the client syncing to the global state of the blockchain, but every single client syncing to the global state of blockchain. It's just that there is no global server to sync to. So when you want to sync, you ask your neighbor, hey, what have you got? If they say, I've got till the current one, you say, good, can you please pass on to me the current blocks? I'll sync up. So that's what the decentralized thing is. Do we need to keep increasing the computer memory or something? Not the memory, the hard drive, right? It's not the main memory issue. It's the storage issue. Yes, you will have to keep increasing your hard drive. But again, hard drive is the cheapest thing in the computer anyway. So it's fine, right? So will the ledger update for everyone? Yes, if you want, it will. So if you are keeping the machine on, like the dashboard, I'm keeping it on. So the copy of the ledger that I see on this server, blockstream.info, is actually updating itself. And Blockstream is just a website who is providing a view of the ledger to general public. It's nothing special. It's not that that's the global ledger. It's just the ledger that Blockstream.info, the company, is maintaining on their end. And they are giving you a glimpse of it. It updates for everyone. Okay.
Sir, I have a question. It's too long
Yes.
to write.
Yeah.
If suppose like Ernest doesn't want to update his ledger and he's supposed to shut down his computer and goes home for one day, and when he comes back, there are several mining blocks. So and he asks his neighbor to forward him the mining blocks. So will he need to update his block or his mining block just before when he left, or will it be updated after the blocks, after those blocks?
So just when he left, there was a universally agreed upon ledger at that point when he left. So his own ledger was updated till that point. Then when he joins back again, he will pick up the longest chain after that. So the previous one is already with him. He just needs to update the new version of it. Okay?
Okay, sir.
That makes
Okay.
sense? So
Got it.
if you are programmers, then think of it more like a Git, like a GitHub. You are making updates, and then the next time you make a pull request or a clone request, then you are getting the entire thing once again. Right? So you're
Okay,
getting
so
the updates.
basically if suppose he left at 100 blocks and
Yeah.
when he opens it's at 105, then he can
Right.
add the 106th block to it.
Not yet. So he has to update till 105 first. The 5 blocks has to be synced first.
Oh, okay.
And then
Okay.
he has the final view of the ledger. Now he can add the 106 block if he wants.
Oh, okay. Thank you, sir.
But it has to be updated first. Everybody has to be in sync. Cool? Make sense? So that's our voting mechanism, right? If you don't add to 105, I can't add. Yeah, exactly. So which one do you add? If you don't add to 105, then the 106 block, you're adding to which one? You have to append to a page in the ledger. So right now, if you only have up to page 100 and you try to add to that one, then you are actually challenging the 101 block created by someone else. So you're trying to create a fork out of the chain. And that's not generally what happens. You wouldn't challenge that 101 block, right? Why would you? That's not the point. You're trying to keep everything in sync. Good. So this is our entire structure for blockchain in case of transfers. Again, just a nutshell, but that's what it looks like for transfers, right? You have this X tokens you need to transfer. You have to let everybody know, like I did know when I transferred to Ernest. And then if now anybody wants to transfer in this public network, it can only be Ernest because he's the only one who has it. Oh, by the way, I forgot. There is someone else who actually got some money. Chunwei, sorry, I forgot. So there is in our network, Chunwei. So Coinbase gave Chunwei some money. What is it? Let's call it NTUC 10. And then Ernest has got, because Chunwei solved the puzzle last time, right? So she got to write those transactions in a block and she got a reward for it. That's a reward. This is the reward for playing along in the network, for maintaining the network. And you see, that's called the incentive design. You're designing the incentive for someone to be active in the network and solving puzzles and be a maintainer, be a miner in the network. So right now, who has money? Chunwei has 10. I had 10, but now I have 5, and Ernest has 5. So that's my global state of the community right now. All of you still don't have any. So now if Chunwei wants to spend, they can. But if Ernest wants to spend, they can. If I want to spend, I can a little bit, right? That's the idea. Now, when Bitcoin started 2009, January 2009, then nobody had any money. So no transactions were happening. So what happened? There was the first block mined. Somebody would mine that. So if I go to the website called coindemo.io, I would highly recommend it because our session is almost over and you should look at something like this to get a feel for it. Coindemo.io is a very good way of looking at what blockchain looks like. So see, here's Satoshi. Maybe I even cut down Sethi. Nobody, right? Satoshi. Satoshi created the blockchain. And then there is nothing in the blockchain right now. It's only the Genesis block, the first block to start everything, because I have to write pages. So think of it as the title page, the cover of the book, of the audit ledger. And now Satoshi cannot do a transaction because Satoshi does not have any money. So the first thing is to gain some money. How do you gain some money? You mine a new block with nothing in it. That's the first thing, right? And you mine the new block, you got 100 in return. That's a reward you got. Here's a new block. Reward is Satoshi's 100. Like I got the 10 when I started the blockchain, right? Good. Now Satoshi says, okay, I have some money. I want to spend the money. Who do I spend it to? There is nobody in the network. So then Satoshi goes out and tries to say, hey, would you please join my network? Somebody please join my network. So let's say somebody joins. Tanya joins in. Good. So when Tanya joins in, Satoshi says, hey, thanks for joining my network. Can you please connect to me? Because if you don't connect to me, I cannot show you the current worldview for the ledger. There is a global worldview, but I cannot show it to you unless you join me. So sort of a friend request, right? You have to make a friend request and you see what Satoshi sees. So what does Tanya see? Tanya sees she doesn't have anything, but she sees the current state of blockchain. Good to know. Tanya doesn't have anything. So Tanya tells Satoshi, hey, how can I be a part of your network? I don't have any money. So Satoshi has two options. One is you can tell Tanya, okay, you go ahead and mine the next block. You'll get 100. Or Satoshi can say, let me do a transaction for you. So let me send Tanya $50 or 50 Bitcoin in this case. And the fund says inputs insufficient funds. So I must find out a fund which I can spend from the 100 from mining that I got, and then I can pay it. Make sense? So now Satoshi still has 100. What happened? Satoshi should not have 100, right? He just spent 50. I just spent 50. How come I have 100? And Tanya still has a 0. What's going on? Anyone? Thank you. So it's not in the auditing system yet. I made the transaction, everybody heard the transaction, but the transaction does not mean it's in the auditing system. So now somebody has to create a block. It says unconfirmed transactions, means transactions not yet in the auditing ledger. So Satoshi maybe mines the next block. So Satoshi says, I picked this transaction, I will mine the new block with this transaction included. So mine a new block, immediately the balance goes to 150. Well, there are two components to it. One is I gave 50, so I received back 50. That's 50 of my old money. And this time I got a reward of 100. So I got 150. If I go to Tanya, Tanya should have a 50 now. Very nice. The next time Tanya says it's plain odd. Two of us exchanging money of no value. Let's expand the community. So you keep on adding more and more peers. And when you have a bunch of other peers, then you ask all of them, hey, can you be our friends? So really belong to this community. If you're not in the community, you don't see anything. So all of these guys belong a part of the community, but they don't have any money. So now they start mining new blocks. So maybe Wanda mines some block, Jane mines a block the next time, and so on. Right? So if Tanya mines instead of getting money from Satoshi, no, it will not create Genesis block. It will create the next block in the blockchain. So the blocks keep on incrementing, not a new block, not a new chain. Does it make sense? So that's roughly what the idea is for transfers. You are just really recording the transactions. Everyone records it. Everyone verifies it, verifies the signature and verifies the amounts. Mining is optional. If you want to maintain the ledger, go ahead and mine. You get reward for that. That's the incentive design. And then you have to publish it. So at the end of the day, it's a public network. It's a public thing. Who sets the puzzle for mining? Good question. It's set automatically in the system, in the software. And it's also an auto-adjusting puzzle, auto-adjusting in terms of its difficulty. Hash functions required to understand it. I'm not talking about it yet. So transaction time depends on when the block is mined. Absolutely. Very, very good question, Timothy. So When you send a transaction, it's not automatically recorded. That means the latency of getting a transaction into the audit ledger is really dependent on the throughput of the number of blocks or the mining delay. And what's the mining delay in Bitcoin? If you take a look, it seems like mining delay in Bitcoin. Let's see. So update. Hard to say. So this is 46, 28, and 17. So that's about 11 minutes. 17 to 11, that's about 6 minutes. Then another 10 minutes, and so on. So it's roughly about 10 minutes per block. Roughly 10 minutes. Not exact, because I do not know how fast people are going to solve the puzzle. 10 minutes is the one that the auto-adjusting puzzle looks at. The auto-adjusting puzzle will adjust the hardness of the puzzle so that on an average, statistically speaking, you will have 10 minutes per block. And this auto-adjustment happens about every 14 days or so. So you get a block, you get an update for the hardness of the puzzle. Cool. Right? So you need to wait about 10 minutes to send Bitcoin. Not quite. So when you send Bitcoin, you are free to send whatever you want. Then you have to keep an eye on the ledger to see which block your transaction appears in. And by the way, if you want to make your transaction appear earlier, you can increase the transaction fee. That means your input and the output mismatch, you can increase that. If it's a higher transaction fee, more likely the miners are going to take it up. Okay. Sorry, it's already 9:30. I should not go any more. Chris, I did not cover a lot of other details, but I think the pace was okay, hopefully. What do you guys think? Is it okay? Did I go too slow?
No, Dr. Surath, I think it's great that you go into detail so that you make sure everyone understands. So I think it's fine. Yeah.
Okay. All right. So, but do remember that I cannot even say how shallow a coverage I did. So it's something like the first lecture of an entire 13-week or 14-week lecture season. Okay. So if you really want to know more about it, then do take a look at so many resources out there. But I would suggest what are the ones that I would like to take a look at. Let me see. So if you're more on the academic side of things, then there is this book by Princeton, or rather faculty members from Princeton. This is called Bitcoin and Cryptocurrency Technologies. And you should start reading this book, or at least you should start looking at their MOOC. They also have a MOOC online. Take a look at the MOOC. Right? So that's a one. That's a very good one. If you're more on the practical side of things, you like to see code more than listen to lectures, which is fine. Then there's something called Mastering Bitcoin. Let me see if I can find the book, Mastering Bitcoin, not the Amazon version. There is a free version on GitHub. So take a look at the Bitcoin book by Tom. This is the Mastering Bitcoin book. It's really, really cool. It goes more in depth in terms of how the Bitcoin mechanics really work in code. Very informative, but very technical. Your choice. All right, pick one. The first one is more academic. The second one is more developer oriented. And I think the club can also help you find more resources and go more in depth about blockchain. All right, this was roughly Bitcoin, not really blockchain. So more you can look about blockchain with the club. Thanks a lot for joining. Thank you so much. All right, Riz, I should stop. It's already 9:30.
Yep. Thanks, Dr. Surath. Thank you for the insightful presentation.
No
I
problem.
think you are receiving great feedback in the chat. So I think the pace was indeed just nice. Yeah.
Where can they reach for queries? The club, right? You should drop a note to the club if you're looking for any queries and if you want to learn more. Right, Riz? They can contact you.
Yep, we'll go right into the publicity soon. Yeah,
Sure, please
so
go ahead.
there'll be definitely, yeah. I think I would just like to take a quick group photo, if that's possible. So I think Victor will help me. We're on gallery view right now, so if there's anyone who is comfortable on turning on their cameras, we will be taking a screenshot right now. So do turn on your cameras. Okay, I'll give you guys maybe another 5 seconds. Right, thank you. I see many people have turned on their cameras. You can see almost a whole screen of smiling faces. So everyone just keep your smiles there for like a few seconds, okay, as Victor takes a photo. All right, thank you so much. So moving on to our few concluding slides. Maybe Victor, give Victor a few minutes to share the slides again. But yeah, I hope whatever Dr. Surath has shared intrigued everyone here and wanting to learn more about blockchain going forward. I think you mentioned that this really just scratches the surface. So there's really a lot more to learn. And because the blockchain space is so huge, there's really a lot to cover. And it is recommended that everyone do their independent learning on the side with all the resources out there today. I think that's very possible. So here's now a clear summary again, to reiterate once again, the benefits in joining our community. So for those who are new to blockchain, you can expect to accelerate your learning with the workshops that we have planned for you. For those who are more experienced, we will be sharing links to external events and resources frequently whenever they are hosted. And so you'll be able to attend those external webinars to improve your skills more independently if you are more advanced. So secondly, Blockchain NTU also gathers diverse group of like-minded individuals. I'm sure some of you is from computer science. I saw people who visit the booth from EEE, from mechanical engineering, from business as well. So everyone here has a common interest of learning blockchain. So you can really look forward to meeting friends who will be equally excited as you to join like blockchain hackathons and build blockchain applications in the future. And lastly, you will be in the loop for blockchain career opportunities. There will be internships and practicums as we had in the past with some of the local organizations that we are in contact with. So yeah. And we also like to, this slide basically summarizes some of our expectations also as we embark on this journey. It's quite chill, but learning about blockchain will take time and effort. So we are really looking for more self-motivated individuals who are willing to push themselves outside of the activities that we have even planned for you. And if you have knowledge in these related fields or an interest in fintech or technological entrepreneurship, this should all be very relevant to you. But nevertheless, as an interest group at heart, we are open to students of all backgrounds as long as you're willing to learn. So I think here is a slide containing some other common question and answers. I think most of them have been reiterated multiple times. So if you have no prior knowledge, for example, you can definitely still join us. The frequency of lessons, we have planned one workshop every week. Most weeks there will be activities going on, so you can check out the schedule on our official website, which we will share in the next few slides. And there will be educational materials posted in our chat group if you join us along the way as well. But most of our activities will take place on Thursday nights, like today. What is the commitment like? So the commitment is quite flexible. Yeah, most of the activities recommend you to join us, but otherwise it's also a lot of independent learning. Yep. Okay. So now if you're convinced to join us, remember to fill out the form at the QR code below if you haven't, as registrations will close by the end of this week. And you can also join, even if you're not joining us, you can still join our public-facing Telegram group, which is the QR code on the right. So in that public Telegram, there's also non-NTU people in there, and it's basically a platform where we do share some blockchain opportunities as well. And we will have a separate private chat for our own club members. So yeah, and you can also visit our official Blockchain NTU website, which is the WordPress link at the bottom, as well as our Instagram and Facebook. You can take a screenshot here, but we'll also be pasting a link to today's slides if you wish to browse through them again. And so apart from this, I think thank you to everyone who has stayed till now. For your benefit, we're also happy to share that there is also a Singapore FinTech Festival coming up at this end of year. You can sign up for the event for free using an NTU email account. It's nothing, no sponsorship or anything. It's just something that I came across personally, and I think it's a really educational event. And yeah, using the NTU email, you can basically sign up for free. So it's do sign up if you are free to attend. It's on the 8th to 12th November. Yeah, so just give us a few minutes as we share the link to today's slides. But otherwise, if you're in a rush, you can feel free to leave the call. Yeah. Thank you. Thank you all for coming today. Let me just paste a few links in the Zoom chat if you guys wish to join the Telegram groups.
All right. Thanks, everyone. See you guys. Bye. Good night.
Thanks, Dr. Surath. Thank
Yep.
you.
Thanks, Chris.
See you soon.